RPC RMM Level 0. At Level 0, an API uses an RPC remote procedure call style. It basically treats HTTP as a transport protocol for invoking functions running on a remote server. In an RPC API, the API tunnels its own semantics into the payload, with different message types generally corresponding to different methods on the remote object and using a single HTTP method, POST. The SOAP services, XML RPC, and POX plain old XML APIs are examples of Level 0. Consider the example of an order processing system using POX. The system exposes a single order processing service at the URL /order service. Each client posts different types of messages to that service in order to interact with it. To create an order, a client sends the following: post /order service HTTP 1.1 content type application /XML content length XX. The server then responds, telling the client the order has been created. HTTP /1.1200 OK content type application /XML content length XX. Order created. Notice the status is in the body itself, not via the status code. This is because HTTP is being used as a transport for a method invocation where all the data is sent in the payload. To check on the list of active orders, the client sends a getOrders request. Post /order service HTTP 1.1 content type application /XML content length XX. The server reply contains the list of orders. HTTP /1.1200 OK content type application /XML content length XX. To approve an order, the client sends an approval request. Post /order service HTTP 1.1 content type application /XML content length XX. The server responds, indicating the status of the approval. HTTP /1.1200 OK content type application /XML content length XX. Order approval failed. Missing information. Similar to the status mentioned earlier, here the error code is part of the payload. As you can see from the preceding examples, in this style the payload describes a set of operations to be performed and their results. Clients have explicit knowledge of each of the different message types associated with each service, which they use to interact with it. You might be asking, why not use another method like put? The reason is because in this approach all requests are sent to a single endpoint /order service regardless of the operation. Post is the least constrained in its definition, as it is both unsafe and non-idempotent. Each of the other methods, however, has additional constraints, making it insufficient for all operations. One benefit of this approach is that it is very easy and simple to implement and aligns well with the existing development mental model. Resources are Level 1. At Level 1 the API is broken out into several resources, with each resource being accessed via a single HTTP method, though the method can vary. Unlike Level 0, in this case the URI represents the operation. Returning to the preceding order processing example, here is how the requests look for a Level 0 API. To create an order, the client sends a request to the createOrder API, passing the order in the payload. Post /createOrder HTTP 1.1 content type application /SN content length XX. Order number 1000. The server then responds with an order that has an active status. http://1.1200 OK content type application /SN content length XX. Order number 1000, status active. To retrieve the orders, the client makes a request to list orders and specifies the filter in the query string. Notice that for retrieval the client is actually performing a GET request rather than a POST. Get/list orders, status equals active. The server then responds with the list of orders. http://1.1200 OK content type application /SN content length XX. Order number 1000, status active. Order number 1200, status active. To approve the order, the client makes a POST request to the approve order resource. POST/approve order number equals 1000. A common example of an API using this style is Yahoo's Flickr API. Looking at the documentation, we see API methods. Looking under galleries, we see the methods listed in Figure 2-4. Figure 2-4. Yahoo Flickr API. There are several different UIs for working with photos. To add a photo, you'd request the Add Photo API, while to retrieve a photo you can use Get Photos. Update a photo, you can request the Edit Photo or Edit Photo APIs. Notice this style is still very RPC-ish in the sense that each resource corresponds to a method on a server-side object. However, because it can use additional HTTP methods, some resources can be accessed via GET, allowing their responses to be cached as in the earlier list orders example. His style provides additional evolvability benefits in that we can easily add new functionality to the system as resources, without having to modify existing resources, which could break current clients. HTTP verbs are level 2. In the previous examples, each resource corresponded heavily to the implementation on the server, relating to one or more methods on server-side objects. Thus, those examples were very functionality-oriented get order. A Level 2 system uses a resource-oriented approach. The API exposes one or more resources order, which each support one or more HTTP methods. Host types of APIs offer richer interactions over HTTP, supporting capabilities like caching and content negotiation. In these APIs, it is common to have a delineation between collection resources and item resources. A collection resource corresponds to the collection of child resources, for example, http:// example.com/orders. Retrieve the collection, a client issues a GET request to this resource. Add a new item to the collection, a client posts an item to this resource. An item resource corresponds to an individual child resource within a collection. For example, http://example.com/orders/1 corresponds to order 1. To update the item resource, a client sends a put or patch request. To delete, it uses a delete method. It is also common to allow put to create the resource if it does not exist. An item resource is generally referred to as a subresource, because its URI implies a hierarchy. i.e., in /orders/1, the 1 is a child. Both collection and item resources can have one or more collection and item resources as children. Applying the order example to level style, the client now sends the following request to create an order. Post /orders content type application /some content length XX. Order number 1000. The server then responds with a 201 creative status code and a location header indicating the URI of the newly created resource. The response also includes a tag header to enable caching. http://1.1.201 created location /orders/1000 content type application /some content length xxe tag 12345. Order number 1000, status active. To list active orders, the client sends a GET request to the /active subsource UN. dir/orders. Get /orders/active content type application /some content length XX. Order number 1000, status active. Order number 1200, status active. To approve the order, the client sends a PUT request to /order/1000/approval. PUT /orders/1000/approval. The client then responds, indicating in this case that the order approval has been rejected. http://1.1403 forbidden content type application /some content length XX. Error. Code 100, message missing information. Looking at the preceding examples, you can see the difference in the way the client interacts with such an API. It sends requests to one or more resources using the HTTP methods to convey the intent. A real-world example of a resource-oriented API is the GIT Hub API. It exposes root collection resources for each of the major areas in GIT Hub, including orgs, repositories, pull requests, issues, and much more. Each collection resource has its own child item and collection resources. To interact with each resource, you use standard HTTP methods. For example, to list repositories for the current authenticated user, we can send the following request to the repos resource. Get HTTP //api.github.com/users/repos/http/1.1 to create a new repository for the current authenticated user. We issue a post to the same URI with HSON payload specifying the repo information. Post http://api.github.com/users/repos/http/1.1 content type application /some content lengths. Name new repo. Description: this is a new repo. Homepage https://github.com. Private false. Has issues true. Has wiki true. Has downloads true. Crossing the chasm toward resource